situations, we're going to discuss how to do that line clipping. Because principle and algorithm is applied for two-dimensional clipping, three-dimensional clipping. Before we start, let me talk about that. Means coincidental and algorithm can also be applied for three-dimensional object. But region code generation, after region code generation, it is very computationally, it is very good. But before region code generation, computationally, it is very slow before region code generation. So it takes lots of time to generate the region code. So that's why some modification came initially published by Cyrus Bake, their original paper, but after that it will be more refined and more easy to understand by Lian Bus. So independent 2D and 3D clipping, and they also introduced more efficient trivial rejection test for general clipping designs. So it's very faster. So let's see the Cyrus Bake algorithm first. We will just make a little introduction about Cyrus Bake, but basically we will learn about the Lian-Barsky parametric equations. So what exactly they did, Cyrus Bake, they are too much worried about the tangent, okay, the aim, the normal vector. So they calculate the normal vector at each point, and with that one, they will draw the conclusion of T. That means after certain times, how T gonna evaluate it and the distance, measuring the distance. So that's pretty neat, but too much math is involved over here. This portion you can see if you wanted to know the physical interpretation of that one. So let's see like that. Suppose if you are over here, so and after T time, you are over here. So this is your P1, this is your P0. So at time T, that means that P0 means from here it is P0. And this one is P1. So after sometimes T, you're gonna be over here. Okay. So what's your position is a P1. What's the position from this boundary you are? So that's gonna be P0. So over here it's a P0 plus this segment. This segment is P1 minus P0 into T. That means whenever T becomes 0, that means you are over here. So T is 0. Okay? So this T is a parameter and its value is like this. 0 to 1. Clear? I hope you understood this one, right?
Yes, sir.
Okay, good. So this is how we're going to measure T. That means in which position we will be. How we measure T and why we measure T. That means a line like this way, and it is actually traveling. It is actually traveling. And whenever we reach this point, that means at certain T, so at that time, we're going to evaluate both the tangent of this and this one. So if this coincide, then we can see that it touches this point. So that's the theory behind of it. So T exists when this one, and that one, and this one. These three constraints should be satisfied for that one. And if T exists, that means we are actually eventually headed to the four bound. You can see we start from T0 every time. We start from T0, and how we gonna reach over here? So this is how we can be sure that it touches the boundary. So this is the potential entering. Just mean we are entering, and this is PL is potential leaving. So when it happens, if this equation will satisfy, and for angle greater than 90, and potential leaving, whenever we found this, then we can say this is the potential leaving. Clear? So this is the algorithm for that one, and take a look on that one. If you don't understand anything, let me know, because that's a pretty neat algorithm. And only the if else is there. There is no vector. I mean, no list or a stack is there. Only the pure mathematical calculation. So I hope it's gonna be pretty good. So for each line segment, okay. So pre-calculated A9 was there, okay, and PI, the potential entering I for each is, and line segment to be clipped. এটাকে আমরা প্রসেস করতে হবে for each line segment, যতগুলো line segment হবে. If line is degenerated, so clip as point. যদি এটা হয়, otherwise we will do this, and for each candidate intersection with a clip edge, there are 4 clip edges. Then if we have that one, calculate time and use sign to categorize this one. You can see the early pictures. This is the sign, greater than 0, less than 0. So that depends on the potential exists and potential leaving. Clear?
Yes, sir.
Okay, good. Okay, we will start this polygon clipping and Nicolli-Nicoll algorithm in our next class. But right now we will be heading towards the right, Liang-Barsky. Let me open another slide for Liang-Barsky. Okay. Can you see that one? The Liang-Barsky?
Yes, sir.
Okay. So here, take a look, that's pretty good. And we will go through an example so that you can understand it properly. A line segment with endpoints x0 and y0 and xn and yn. So we can describe the parametric form like that way. Whenever you introduce some equation with a parametric form, that means you introduce a new variable. So we are introducing a new variable, x0 plus u delta x. If you recall that one, whenever I draw these things, I mean, just a second. Huh? Hello. I'm in the class right now. হ্যাঁ লেখা শুরু করো এক্সপ্লেনেশন শুনে। P1 minus P naught T. Just mean this is delta P, right? So you can easily figure it out with that equation that x naught plus u delta x, where u is replacing T over here. You got my point? Hello?
স্যার আরেকবার একটু বলেন তো, বুঝে নেই।
একটু আগে যে দেখালাম P naught সমান P1 minus P naught T. তাহলে P1 minus P naught means delta P. আর T means over here U. তাহলে দেখো সেম ইকুয়েশন কিনা।
জি স্যার, বুঝতে পারছি।
Okay. So how many equations are there? এই দুটোতে কতগুলো ইকুয়েশন আছে?
স্যার দুইটা
দুটো ইকুয়েশন আছে। But basically we will heading towards the 4 equations because we have some inequality where delta x is xn x naught yn y naught, মানে p1 p naught p1 p naught, something like that. Okay, so more efficient that Cohen-Sutherland algorithm, earlier I have already talked about it. It's very faster. So you can see over here that xw mean, that's mean the left coordinate point, left clipping boundary, and xw max, the right clipping boundary, and the bottom clipping boundary and the top clipping boundary. So delta x is this one. So we have 4 inequality equations and can be described as upk less than equal to qk, where k is 1, 2, 3 for the 4 boundary. So this 4 inequality can be described as upk less than equal to qk. So where the p1, that means that we need to define the 4, since k is 1, 2, 3, 4, so we have 4p and 4q. So u, we need to find out the parametric equation of u, and depending upon that u, we will decide it whether this line is intersect with the clipping boundary or not. Okay, so how are you going to find out? uk is qk divided by pk, where is p1 is minus delta x, p2 delta x, p3 minus delta y, p4 delta y. q1 x naught minus xw mean, q2 xw max minus x naught, and so on. So what Lian-Gursky says, when pk is less than 0, as u increases, line goes from outside to inside. That's mean entering. When pk is greater than 0, outside, that's is exiting. And when pk is equal to 0, line is parallel to the edge. That's mean line is not intersect the clipping boundary. If there is a segment of line inside the clip region, a sequence of infinite intersection must go entering and exiting and entering, like that. You can see a sequence. This is entering, exiting. But this is a pictorial view for that one. But we need to do some math so that we can understand. So what's the Lian-Gursky algorithm clipping? First set u min equal to 0 and u max equal to 1. Then calculate the value of u. If u is less than u min or u is greater than u max, then ignore that line. Otherwise, classify u values as entering and exiting. If u min is less than u max, then draw a line from this one. u min is less than u max, তাহলে লাইনটা ড্র করব কিভাবে? Always u min দিয়ে, that's it. This is our point, and u max দিয়ে, তার মানে পয়েন্টটা লাইন ক্লিপিংটা যাবে এই পয়েন্ট দুটো দিয়ে এবং এই পয়েন্টটা দিয়ে। আমাদের এটা বের করতে হবে। We have already known this element if you know u min. Okay, so let's do the math. Suppose the clipping boundary is 10. 10 means if the clipping boundary is 10, that means this is a clipping boundary 0, 0, 10, 0, 10, 10, 0, 10. And we have some initial point p0 and pn minus 5 over 3 and 15,9. So we need to find out all the u. So u1 is left, u2 is right, u3 is bottom, and u4 is up. So q1, p1. We know that q1 means x0, xw mean. So x0 is minus 5 minus 0. This is a 0. So we have 1 by 4, which is less than 1. So this is entering. You write 3 by 4. As U min is less than U max, so U max is exiting. We have minus half. Minus half cannot be a point, as U must be between 0 to 1. So minus half is not our desired point. So we ignore this one. And we ignore that one. So we can, from this equation, we can see that the line must be intersect with the left boundary and right boundary as it is entering and exiting. And that's how it happens. Okay. So now we have our U min, we have our U max. So U min is 1 by 4, U max is 3 by 4. So we need to find out this point, the intersect point where the left boundary intersect with the line. And that point will be calculated by this one. So 26. So 20 and 6 gonna be the value. So we have draw a line from this to that one. So minus 5, 20 into 1 by 4. That's mean minus 5 plus 4. That's mean minus 1. We have this one and comma this one. So that's mean 0, 0. Minus 5 and 20 divided by 4, 5. That's mean this is 0. So we need to draw a line from 0 to 3 plus this is 6 by 4. That's mean 2 by 4. 3 by 2. That's mean, so this point gonna be 0, comma 4.5. And what is this line? This line gonna be minus 5 and 15. That's mean 10. We have 10 over here. And 3 plus this one. So 9, 4. That's mean 6. This is gonna be our 2. That's mean half into 6. Half into 6 means 9. 9 plus 3. That's mean 12. So that's how we're gonna decide our point. Okay. So this is our point. So this is another example. You can walk through that one, and we will talk about the Nicol-Lille-Nicol algorithm in our next class. Okay. So do you have any questions?
No, sir.
Okay, let's finish the Nicol-Lille-Nicol today. That's pretty easy. It's kind of vision code generation, but in a different thinking. Let me see. Let me show you that one. Suppose we have this one and this one. This is P, this is P1, and this is P2, and this line is P dash. So if P dash bar, that's been a tangent of this line, is greater than this one and less than this one, then we can say that this line is in between this and this line. You got my point?
Yes, sir.
তার মানে কোন একটা লাইনের tangent বের করব, tangent বের করা তো আমাদের জন্য কোনো big deal না, right? If we know this point, we can easily figure it out what's the tangent. If we know this point, that's mean x and y, and this is x dash and y dash, so what's gonna be the tangent? Just mean y dash minus y, x dash minus x. That's our tangent, right? So you need to figure it out all the tangent, and if this tangent lies between these two tangents, that means this line lies between this line. Clear? So that's our basis for the Nicol-Lille-Nicol. Now it says that if we have a 4 boundary, so a point can be over here, can be over there, or over there. 4 corners, or this way, and this way. Clear? So if we can consider only these 3, that means we covered everything, right? Because if we can figure it out this one, we can easily figure it out that one, and that one, right? If we figured out these things, we can easily figure out this one, and this one, and this one, because these are all symmetry, right? বুঝা যাচ্ছে কথাটার মানে?
Yes, sir.
Okay. So that's why we are dealing with 3 pictures. That means the corner, left side, and the middle one. And we will join each corner point to figure it out the tangent. So if we do like this way, if some lines falls in that section, okay, let me draw this over here. So suppose our point is over here. That's means 3 scenario. So we will draw this line like that way, and this way, and that way. So say for example, this is 1, 2, 3, and 4, and this is P. So if we have a line, suppose like this way, so you can see if a tangent P and 1, and this is, say for example, our point, not 0. So if it happens like this way, if this equation is satisfied, then we can easily say that this line is crossing the left boundary and the top boundary, right?
Yes, sir.
So this is how nickel overcome the test cases. Okay? বুঝা যাচ্ছে?
Yes, sir.
Yes,
Okay,
sir.
great. So any questions so far?
স্যার দুইটা লাইন যদি অ্যাকসেপ্ট করেছে তার মানে এটা আমরা ধরতে পারি স্যার, যেমন স্যার P1 আর P0।
আমরা যেটা করব, এই আমার এই 4টা লাইন ইনিশিয়ালি জানা আছে, এই রেড 4টা লাইন, ঠিক আছে? পয়েন্টটা যদি লেফট সাইডে থাকে, তাহলে আমি আইদার এই দুটো দিয়ে টেস্ট করব, অথবা এই দুটো দিয়ে টেস্ট করব, অথবা এই দুটো দিয়ে টেস্ট করব। যে টেস্ট আমার সফল হবে, তাহলে বুঝতে পারবো যে এই লাইনটা, যেমন ধরো যে এই এখানে যদি একটা লাইন থাকে, মনে করো 5, তাহলে এই লাইন এবং এই লাইনের টেস্ট যদি ইকুয়াল হয়ে যায়, তার মানে আমি বুঝতে পারতেছি এটা লেফট বাউন্ডারি এবং রাইট বাউন্ডারিকে ইন্টারসেক্ট করে। এই টেনজেন্টটা আমার যে পয়েন্টটা আছে, যে লাইনটা আছে, লাইনের তো এন্ড পয়েন্ট দুটো জানা থাকবে, ওটাতে টেনজেন্ট বের করবো। ওই টেনজেন্টটা যদি ফল করে এটা আর এটার মধ্যে, তাহলে আমি ইজিলি বুঝতে পারবো এটা লেফট বাউন্ডারি এবং বটম বাউন্ডারি দিয়ে এটা ইন্টারসেক্ট করতেছে, রাইট? সো উই নিড নট টু চেক দিস ওয়ান অর দিস ওয়ান। সো আমার চেকিংটা ট্রিভিয়ালি আমি রিজেক্ট করতেছি, আমি বুঝতে পারতেছি আমার বাউন্ডারি কন্ডিশনগুলো অ্যাচিভ করতেছি। ক্লিয়ার?
ইয়েস স্যার।
Okay, if you don't have any more questions, we can quit, and next class, একটা ক্লাস টেস্ট দিয়ে পাবে এটার উপরে। ক্লিয়ার?
ওকে স্যার।
ওকে।